Hi. I go to a lot of fire meetings, and I represent NOAA at a lot of the NOAA. I don't know why I said that, because I'm nervous. NASA at a lot of the fire meetings. And I can't tell you how many times people come up to me and they say, NASA, what are you doing here? You have nothing to do with fires. What does NASA have to do with fires? So I'm going to answer part of that question today. The little red dots are fires. This is an active fire detection product. This is from MODIS, but we also have the follow-on VIIRS. That is a NASA NOAA satellite and sensor. You can see this is a really cool image because you can see green up as it becomes green and fires burn, and you can see the seasonality across the continents, and you can also see the snow cover. So you can see the northern and southern hemisphere going back and forth. The fire detection data is a way that people can locate fires. We can find fires that people might not have known about before. And this is a product that's easily downloadable in text or GIS files, and it's free. All NASA data is free. Fire is integral across landscapes. Fire integrates carbon cycles, nutrients, micronutrients. And in this model, this is data and a model put together, the green is smoke. So you can see how fire is connected across continents. Sea salt is in blue, and the sulfates are in white. In the longer term, the smoke from fires in the Sahara Sahel is connected to the Amazon, and that's the reason there's enough nutrients for the Amazon to have the rainforest in the long geologic time frame. And also, smoke can be transported to the Arctic, and if it's transported to the Arctic and deposited, then it can cause melting more quickly than might otherwise happen. So this was a really big fire season this year, and it's ongoing. I had to turn in these slides in November, so these data are no longer completely telling the truth. The Southern California's fires are still burning, and the fire weather does not look good. The Taylor fire is 20% contained as of today. 10 hours from when I left my hotel. And the prognosis for the next days is not good. They continue to burn. The number of fires is still less than our 10-year mean, except the area burned is now at 9.34 million acres. That's a lot of area burned for the United States. As a matter of fact, from our entire record from 1960 to 2000, there was only 1 year that acres burned went over 7 million acres. That was in 1963. Since that time, there's been 10 years we've gone over 7 million hectares. Since 2000, and 5 years, we went over 9 million acres. That's a lot of area burned, and that's an increase in the area burned and the fire weather danger. Also, the California fires here, I have them at $2 to $3.3 billion. The cost of the Northern California fires now are at $9.4 billion when I looked this up. And the cost to California is $180 billion. And that's according to AccuWeather and according to, it was an economics magazine, and they're saying $500 billion. So fires cost a lot of money to attack. NASA data is even more important because suppressing fires costs so much money. If we could do something before, if we could learn something about the fires and have more mitigation and prescribe fires on the landscape, then that's helpful, and we could save money because fires are quite expensive. This wasn't only a large fire year in California, it was a large fire year in many parts of the world. In Montana, most expensive fire season. In 2017, the most expensive wildland fire suppression costs on record. Portugal had catastrophic fires, Chile, Argentina, Guatemala, Africa, and Russia. And these were all fires that the NASA Applied Science Program disasters helped to respond to. So now if we change gears a little bit, we have the NASA Applied Science Program Wildland Fire Program. And what we do there is we try to use NASA data, science, technology, methods, and we have a partner, whether it's a Forest Service or BLM or the EPA, and we try to make the data applicable within their system. And like I said, the cost of suppressing fires is very expensive. So if we can do something beforehand or during active fire or post-fire, that's great. We have our project separated into pre-fire, active fire, and post-fire. We have a couple pre-fire activities, projects. One on the left is led by Birgit Peterson, and what she does is she uses she infuses land fire with LiDAR data. And LiDAR data on the surface will show you the structure of fuel, so you know how much fuel could burn or is on the landscape that might burn or needs to be mitigated. So this is a really important data set that has been infused already into land fire. On the right-hand side, Jim Vogelman is leading a project that looks at grasslands. Grasslands are different than forest in that there's more rain, there's more grasses. And this is an underrepresented type of fuel. We don't look at this fuel enough. And these fires can be very dangerous and very deadly, grassland fires. So we've had a lot of success with Jim Vogelman's work as well. Our next project is an active fire project, and this was led by Wilfried Schroeder, and he's been incredibly successful as well. The program has been successful. We're winding up, and there's many success stories. What he's done is he's taken NASA algorithms, most recently from VIIRS, and he's ported them into the Forest Service so they can download and use our data with our algorithms any way they want. And they communicate it properly in the way that the Forest Service and the Forest Service managers want this information. And they organize where people and resources may go. So that's one success. But they took it even a step further. They took CAFE modeling with Janice Cohen's model, and they can initialize with VIIRS data, and it's a very high-resolution model that can give firefighters enough time to get out of the way in case there is a fire that could overrun them. We're only talking minutes, but it has a lot of potential to actually save lives on the landscape. And also, in this project, Janice Cohen, and this image actually is she has worked with the Forest Service, and what they're trying to do is they're trying to look at post-fire activities or pre-fire activities. So they are trying to figure out where they can mitigate, where they can burn, where they can suppress fuels. So they can either do whatever mitigation techniques they can, and they test it through the model so they know whether it works or not. So she's had a lot of success with that, she and Wilfried. The next projects, maybe I didn't push the button firmly enough. There we go. Oh my goodness, I did. I went too far. You didn't see that. All right, this is one that I wanted to highlight, and we haven't highlighted this project before, and it gets a whole slide because they're doing such a great job. This is a post-fire project, and what they've done is they've taken a tool that you could use. If you had a particular forest or landscape that you're interested in, anybody could use this tool. It's going to be fully available, and we're going to have a training class early in 2018 through RSET training, NASA RSET training, and they map burn scars. And this data product, or this tool, has been ported into the MTBS system so that they could map and have mapped double the acres and about 75% more of the fires, because we used to miss all the little ones. So another successful NASA Applied Science Wildland Fire project led by Josh Picotte and Stephen Howard, who's recently retired. And lastly, our last successful project is led by Karen Tabor at Conservation International. And what she's been able to do is she's been able to get out to remote regions and talk to people in these smaller communities and put handheld devices in their hands so that they know where fires might burn or where fires are burning. They'll look at fire weather and they'll say, okay, well, we can burn our crops today or not. So they have more information by which to make decisions. And she's made it look like they want it to look. And this has taken a couple years to work up with this and a lot of talking to people in these remote regions. So they'll be able to know also where fires are burning so they can put them out, where fires are burning illegally so they can go and find people. And the other application that she's found with this is sometimes there's endangered species. And so they can stop the fires or burn when it's necessary in order to protect the endangered species. So with that, Vince, Lawrence, and I have had a lot of success with these projects, and we're happy with all of them. They make it easy to talk about our pre-active post-fires and what NASA can do with large satellite data to help people on the ground in wildland fire communities.